liquid crystal display. That is LCD. What is the features of LCD? We'll see that. First one is operating voltage 3.3 volts to 5.3 volts. Alphanumeric LCD display module. The LCD available in 8 by 2, 12 by 2, 16 by 1, 16 by 2, 16 by 4, 20 by 2, 20 by 4, 24 by 2, and 40 by 4. Each character is built by 15 by 8 pixel box. 15 by 8 pixel box. Can be work on both 8-bit and 4-bit. It is also display any custom generated characters. Available in green and blue color. Current consumption is 1 milliamps without backlight. So this is the one type of LCD and this is another type of LCD. Okay, this one is green background, this is a blue background. This is a we already discussed about the 5 by 8 pixel box, which means this is a 5 from 0 to 4 and from 0 to 7 this is a 8. Okay, 5 by 8 is the pixel box. So pin configuration of the LCD 16 cross 2, 16 by 2 LCD. So it is have a 16 pins. Total is 16 pins. In that, first one is VSS, VDD, VE, RS, RWE, which means enabled from D0 to D7, LED anode and LED cathode. Okay, let's see the pin out of LCD. So first ground is connected to ground. Next VCC connected to the 5 volts, and we are not connected to the this pin conference. Next coming to RS, RWE from D0 to D7 pins and LED anode and LED cathode. So what are the requirement for the conducting the experiments? Experiment requirement. First one is the personal computer, Arduino software, Arduino Uno board, universal USB cable, breadboard, and connecting wires. Next one is LCD 16 cross 2, potentiometer, and resistors. Okay, we'll see the connections of the LCD. So first, pin number 1 and pin number 5, pin number 6 is directly connected to the ground, and pin number 2 is connected to VCC, and pin number 15 also connected to with the LCD VCC with the help of resistor, and pin number 4 and pin number 6 of LCD is connected to pin number in the Arduino pin number 2 and pin number 3. So LCD pin number 11 is connected to 4 and 12 pin number is connected to 5 and 13 pin number of LCD is connected to the 6th pin of the D pin of digital pin of the Arduino, and 14 pin is connected to 7th pin of Arduino Uno, and pin number 3 is connected to the again ground. Okay, this is the connection diagram. You can see already discussed. So pin number 1. So first this row is connected to positive and this is connected to negative. Okay, what is the positive? Pin number 2 is connected to ground. Sorry, 5 volts. And what other pins are connected? Next, LED anode. This pin is connected to with help of resistor. We already discussed. Next, V pin is connected to resistor and one pin is connected with potentiometer. V not pin connected to potentiometer of middle pin, and potential pin one pin connected to ground, another pin is connected to VCC. So RS pin number is connected to 2 and enable pin number is connected to 3. So RW is connected to ground. So next, pin number 4, DB4 pin number is connected to 4. Next, DB5 pin number is connected to 5 and DB6 is connected to 6 and DB7 is connected to 7 and LED is connected. This last pin is 16 pin is connected to ground. Okay. So this is the experiment. We need to print this one. So integration of LCD to the Arduino. in the Tinkercad software. So for that, we need to go on, click on create circuits. We'll go to the interface of circuits in the Tinkercad platform. So we know already this is a component, this is a list of components, code, start simulation. Okay. From I'm bringing the Arduino to interface. Arduino bringing to interface. Next, what we need? LCD. 16 cross to LCD. So I'm bringing the 16 cross to here. LCD. LCD. 16 cross to this one. I'm bringing to here. So we need also on breadboard. Sorry, go back. Just delete. Here's the components. Okay. LCD. Next, we need breadboard. Undo. Will be breadboard. Breadboard. This one I'm bringing to here. Just minimize it. Minimize it. Arduino. Here. We can place the breadboard. So for that, this is Arduino. Sorry. Arduino. And here. Okay. Next, we need this pot. Potentiometer. Potentiometer. I'm bringing to here and place there. Sorry, where is the LCD? LCD. Place there. Okay. So first I'm taking the ground pin. Where is the ground begin? 5 volts. Minimize it. Okay. So 5 volts is connected to just connected to plus 1. Okay. Next ground is connected to we know already was to and change the color to red and this one changed to black. Okay. So I'm bringing to here. So we know already connection. First one is ground. Ground is connected to this one. Okay. This straight line. It's the straight line. Next VCC connected to next VCC. So connected to 5 volts. In this color, this is a red. So it's a red. And third one is connected to potentiometer. So I think this is the potentiometer. Okay, click here. Just for change the potentiometer to here. So this is red. So we need to connect to red. And this is black. And this is black. No, black. Which means ground. So I'm changing the color to black. Okay, this is completed. So next RW pin is connected to ground. RW pin is connected to ground. Done. Next, I'm taking resistor, resistor. From where to where? From LCD here to 5 volts. The value is 1 kilo ohm. Perfect. Next is connected to ground. So this is a red color. Go to color, and this is the red color. This one is completed. So RS pin goes to pin number 2. RS just like that we go to here and to where to here to here. So I'm changing the color. So first green. Next EW is connected to pin number 3. So pin number 3. Perfect. I'm changing the color to purple. Next what is that? Next D04. D4 from 4. So from 4 to just and on shift control and right. Hold the shift and moves down. Okay. So from pin number D4 to 4 of it. Next pin number 5 to here 5 and pin number 6. Pin number 6 to 6 and pin number 7 and pin number 7 to just cancel this, delete this line. We'll make it a straight line and pin number 7 and pin number 7. Okay. So connections are perfect. Connections are first ground, ground. Next VCC, VCC, PO connected to middle number port, RS, AW, D4 to 3, D4, D5, D6, D7, LED to this 5 volts and down to ground. I'm changing the color. This purple is the same color, so I'm changing the colors. So purple. Next, I'm changing color to so something colors, and this one is color to pink. And this one is goes to brown, and this one is goes to yellow. Okay, connections are done. So next, what is code? So I'm clicking on the code. So this code is available in the description. This code is available in the discussion. Just I'm explaining the code. Click on the line. First one is the hash include crystal.h is a LCD library. LCD library. And second one int seconds equals 0, which means seconds equals to 0. I'm storing seconds equals to 0. Next, liquid crystal LCD 2, 3, 4, 5, 6, and 7. So and 7. So coming to which means so RS pin is connected to enable pin is connected to 3, D4 is connected to 4, D5 is connected to 5, D6 connected to 6, and D7 connected to 7. So next wide setup. This is from year to year wide setup. Just I'm initializing the 16 to class LED here. Next from year to year wide setup. So first set kernel 0 comma 0. 0 comma 0 means so always in the I know starts with 0. So here 0 and 1. So next 2, 3, 4, 5, 6, like up to 16 characters in a one row. And the second characters again 16. So which means here what is the number? 1 comma 16. And here 0 comma 0. Okay, so the set cursor 0 comma 0, which means cursor is there. What I'm printing? Hello world. Next 0 comma 1. So 0 comma 1, 0 comma 1 here, 0 comma 1. So what is that? Seconds. I'm printing the seconds. What is the seconds? We already stored the seconds in 0, which means first 0. Next delay 1 second. After 1 second, so first print the hello world 0 and wait 1 second. Next seconds plus equals to 1, which means seconds equals to seconds plus 1. So what happens seconds equals to? We know that 0 here. We know 0 here plus 1 plus 1 equals to 1 in seconds. We are storing the value in seconds. Again loop is repeating. Hello world 0 comma seconds. What happened? 1. Next 1 second wait. Next again 1 second. Again second. So equals second plus 1 means 1 plus 1 equals to 2. Like that until the power of to the unknown board the while loop run continuously. Run. Okay, we'll see the I'm the run the code. Just wait a minute. I'm erasing all things. Run the code. So next, start simulation. Start simulation. So hello world 0, 1, 2, 3, 4, 5, like that is continuously runs until the power cut to the Arduino board. Arduino board is power supply, which how to know that? You have a LED power on here. LED power on to the Arduino board, which means power supply is connected to the Arduino board. Then the LED Arduino LEDs turn on. So it's going 28 seconds, 29 seconds, 30, 31, 32, like that is going on. So just start simulation. Again start the simulation. Like that is going on. Okay. So next we'll do the another experiment. I'll change something code here. I'm changing code here. Okay. So I'm changing because this 16 will be color. So I'm changing into here. I'm changing the name. Just click on that. Changing the name. What name? Myself, Ashok. So myself Ashok. I'm writing myself Ashok. Yes, okay. How many characters? 6 plus 7 plus 5, 12. Okay, next. My something altogether number 21. So what is the altogether number? 24 05 04A 410 61. Okay. So this is a capital letter. Okay. Click on start simulation. So it is going error. LCD dot print LCD dot we have some error. We'll see the what is error. Like is showing like is error. What is error? Error character while loop. So what is the error? So here error. I'm forget to give the double quotes here in front of the G. So I'm giving double quotes. Just wait a minute. Actually, I forget the double quotes here. So click on here double quotes. So here also double quotes. This one and here also. So then start simulation. Then see Madam Ashok 24041062. Perfect. Stop simulation. Next, go to code and change something. I'm changing to set cursor 0 comma 0 comma 1 0 comma 0 0 comma 1. So I'm changing to wait 1 second delay. I now did to this line and delay 1 second going to continuously run. Okay. So like that we need to continuously. We'll do some experiments on LCD with Arduino. Proximity sensors. What is it? Proximity sensors. A proximity sensor is a sensor able to detect the presence of nearby objects without any physical contact. The proximity sensors offers emitted an electromagnetic field or beam of electromagnetic radiation and looks for the change in field of return signals. The types of proximity sensor. First one is inductive sensor, capacitive sensor, optical sensors, and ultrasonic sensors. Inductive sensor. We'll see the working principle of inductive sensor. Sensing, this is a sensing direction, and operation inductor. This is the waves and object detection coil. Sensing the objectives of metal, eddy current, metal objects. We can see target is absent, this statement after is present in this line, and target is absent as this line. Next, proximity sensor is capacitive proximity sensor. The target is absent. This is the plate, oscillator, trigger circle, output switching device. This is a target. You can see the state line, the echo is state line, the target is absent. Here also. The target is absent, which means the echo is state line. The target is present, the echo is like this. You can see echo. And next is the ultrasonic sensor. The sound wave is above normal hearing frequency is called as ultrasonics. The frequency around 40 mega kilohertz around common. Subsonic sound 20 fixed, sonic sound 2220, ultrasonic sound less than 20 kHz. What is the working principle of ultrasonic sensor? These are for assume that this is a sensor, this is an ultrasonic sensor. It emits the signals and this is the object and detect by the signal and return back to the sensors. Return back to the sensor. This is the length of the travel by wave. So that is 2x distance equals to velocity of sound and time. This is the ultrasonic sensor module. The HSSC SR04. What is the operations? We'll see the operation. So this is a trigger, this is a sound, 8 cycle sonic burst, and this is echo. After transmitting sound from here and receiving sound from here, this this length is called high level potential to time travel of the sound. We can see here working principle of this is the ultrasonic sensor and this is the they have a transmitter and receiver. The transmitter transmits the echo and this is moving to detect the object. So it is come back to the receiver of ultrasonic sensor. The echo come back to the receiver of the ultrasonic sensor reaches. So this one is data transferring unit and this one all data the time gap from the sending signal to receiving the echo. Trigo and echo VCC ground. VCC connected to 5 volts of Arduino and ground is connected to ground of the Arduino. Okay. Next, distance 2x distance equals to velocity of sound x time. 2x distance equals to 344 microseconds x into time in this. So that the distance equals to 172 into 100 into time into 10 to the power of minus 6. So distance in centimeters equals to 0.172 into time. So thus but HX HCSR04 specifications, which means ultrasonic sensor specification. So working voltage is DC 5 volts. Working current is 15 milliamps. The working frequency is 40 kilohertz. The max range is 4 meters. The minimum range is 2 centimeters. Which means so it less than 2 centimeters can't measure and greater than 4 meters it also not measured. So measuring angle is 15 degrees. Trigger input signal 15 micro TTS pulse. So what is the benefits of ultrasonic sensor? Detect the small objects over a long distance, independent of object surface and texture, independent of environment noise, light, temperature, steam, fog and dust. Good? Good for soil materials like material, glass, wood, paper, plastic, roller goods is tensile, textiles, bulk goods is sugar, flour, potatoes, and liquids are water, soil, juices. So next experiment is what is the aim? To design a smart system to find the distance of an object and display in a on-printed serial monitor. So what are the experiment requirement? So personal computer, Arduino mega board, universal USB cable, breadboard connecting wires, and ultrasonic sensor. That is the sensor specification is SCSR04. Okay, this is a code as include this is a definition 2, 3, 4, 5, 6. The liquid crystal display pin number 9, pin number 10. This we know that the white setup, the configuration. We can see the configuration. So when I discuss VCC connected to VCC, ground is connected to ground, and trigger ego connected to 9 and 10. And USB cable TX and RX. PC is the connected to the PC and serial port. How to connect the ultrasonic sensor to the Arduino. Okay. For that, I'm opening the Tinkercad software. Just click on the create circuit. So open the search the components Arduino Arduino to here. Next, ultrasonic sensor ultrasonic sensor. So I'm taking to here. Okay. Next, connect the ultrasonic sensor with Arduino using the connecting wires. First, take the ground connected to here. Next, VCC VCC. So I'm just connected to black color, black, and this connected to red color. So trigger pin connected to 9. Next, echo pin echo pin is connected to pin number 10. Okay. So we'll open the code. So I'm changing this color. Just go to this one. I'm changing color. So click on here, purple, and this also pink. Similarly, there and go to yellow. Okay, go to the code. Click text. Continue. So just paste the code. Okay, just paste the code. Okay. So trigger pin is connected to pin number 9 is correct. Trigger pin is connected to pin number 9. Echo pin is connected to pin number 10 is correct. Okay. Next, long duration and int distance. Coming to this is a wired setup from year to year. Wired setup serial begin and in. I'm just initialize the serial monitor. Next, pin mode, trigger pin output, and pin mode echo pin input, which means trig pin. Trig pin means 9. 9 output, echo pin connected to 10. So input. So next coming to while loop. So this is a while loop. So first digital write trig pin load 2 seconds micro seconds to 2. Next high 10 seconds. Okay. Next duration. Duration equals to pulse into echo pin comma high. So distance equals to duration by 58. Okay. So duration by 58. So serial pin. So distance and serial pin distance and serial pin tail centimeters. Okay, we'll write it. Click on start simulation. Just click on start simulation. Is simulation just so just I'm drawing this code to this side. Okay, we can see serial monitor here. Just so clear all. So okay, 120 centimeter. You can measure here. Can measure the 35 centimeters perfect. Next 102 103 centimeters. 141 centimeters. Okay, so it's not in range. Perfect. Here you can see 160 centimeters. Okay. This is distance measured by ultrasonic sensors. We will print in the serial monitor. In the next experiment, we will do the. So what are the distance measure? What is the distance measured by ultrasonic sensor? Will measure print in the serial monitor. Okay. And next experiment is so ultrasonic sensor measured by distance will print on the LCD. So for that we need LCD. So I'm clicking that LCD serial monitor clear. LCD 16 class 2. Okay, I'm placing here, and we need another breadboard. This one is I'm placing here. Okay. Next one is potentiometer. 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 I'm placing here. Just zoom it. So with we need to connect it to pin number Okay, and so I'm taking first y positive is connected to, and ground is connected to. So this is I need to change to black color. Okay, next first is ground. Okay, next is power. So this is red color. I'm just moving this one with respect to state. For this, I'm changing to here. Okay, this is red. So this is red color, and this is connected to here. Okay, for this is the ground, and this is red. Okay, this is I need to change to black color. So I'm changing to black color. Next, so we know that already connected. Next is RS pin is connected to pin number 2. So RS pin, just click here, come like this. So pin number 2 connected to pin number 2, and this is connected to ground. Perfect. This pin is connected to pin number 3. Okay. Next, what I'm saying D4. D4 from here. D4 I'm clicking here. So pin number 4, D5, pin number 5, D6, pin number 6, and D7. So pin number 7, we take the one resistor. So for that, and just drag down side. Yeah. So I'm changing the color. First one go to green, and second one is that blue, and and the third one purple. Fourth one is that pink, and fifth one is that brown, and sixth one is yellow. Okay. Next, so I'm taking the one resistor to 5 volts. Resistor to 5 volts. Next, this one to ground. Okay, this is black color. So I'm just click on the black color. Okay. So next I need to take the ultrasonic sensor. So click on ultrasonic sensor. Ultrasonic sensor. I need 4 pins ultrasonic. Just I'm click here. Okay. So I'm taking here as a VCC. So I will connect to here. Just I'll move this side. Okay. I'll move to this side. So VCC connected to plus, and ground is connected to minus. So this is red color, and this is black color. Trig pin connected to pin number 9. So pin number 10. So trig pin is connected to pin number 10. Okay. Next, echo pin connected to pin number 9. Okay, pin number 9. Perfect. Next, what is the connections are completed. So we write to the code. So click on the code. Just come on side. So this is the ultrasonic code. So I'm remove this code. So this is the code for the LCD. Okay. So for let's start simulation. I'm checking if LCD connections are correct or not. Okay. So allow all 3, 4, so LED connections are perfect. So in this code we need to add the ultrasonic sensor code in the code in this code. Okay. Okay. Go to the code. So I'm writing the code first and define the hashing library. This LCD library. Next, trigger pin is open. Clock duration, long into distance, in seconds is not required. Next, liquid crystal dot LCD 1, 2, 3, 4, 5, 6, 7. We already know that 2, 3, RS, EA, E, D4, D5, D6, D7 pins are connected to the 2, 3, 2, 4, 2 to the 2, 3, 4, 5, 6, 7 pins respectively. Coming to the white setup, begin LCD dot begin. So serial monitor also begin. Sprint. This is not required because we are print the data on what are the this what are the distance measured by the ultrasonic sensor that is measured in print in the LCD, not in the serial monitor. So that is not required. This is a pin setup and pin mode. So while loop. So coming to first, this is the measuring this code for the measuring the first what to do trigger pin low. So next trigger pin high 10 seconds, which means the echoes are go to the measure the object and come back to the receiver of the uh, ultrasonic sensor in a 10 seconds. Next again, so low. So duration equals to pulse in echo pin dot high. So distance equals to duration by 58. So next set cursor 0, 0 means which corner and LCD 1 println distance. What is the distance measured in? What are the we are store the data in distance, which means with the help of ultrasonic sensor we measure the distance between the object and ultrasonic sensor. The data stored in distance. So that distance so print the on serial on the LCD. So for that serial dot LCD dot one println distance. Next LCD dot print so centimeters. Okay. Click on start simulation. Start simulation. Some error is there. So I'll check the error first. So I'm just click on start simulation. I'm clicking on start simulation. So it is measuring 142 centimeters. Okay, just minimize it. Click on this. This is the one you share here. It is doing 142 centimeters. Just unmodify this. So 49, 30, 36, 90, 102, 106, the 106 centimeters. Okay, 140 centimeters, 140 centimeters is perfectly matching. So I'm adding me some code. So if the distance is less than 50 centimeters, so it is safe. So less than 50 to 100, it is warning, and the distance above 100 is a danger. Okay. First, I'm writing if condition if this distance if greater than 100, which means 101, 102 is greater than 100, which means the danger. Next, it is not satisfied, else if. So distance greater than 50 and distance less than 100, which means the distance must be in between 51 to 99. Okay. So I'm writing another condition. What is the condition? If else the distance less than 50 distance less than or equals to 50 centimeters, which means 0 to 50 centimeters. That is safe conditions. Or else status unknown. Okay, we'll see this condition. Just click on start simulation. Click on start simulation. We know 124 centimeters, which means above 100. That's a danger. Okay. So I'm coming to in between. So the 65 is in between the 50 and 100. So it is a warning. So coming to less 28 centimeters, it is a safe. Okay. For example, I'm changing the distance. It is a 200. 200. So it is a for example 80 to 200. Okay. This is 80. For example, this is 100 and this is 100. Okay. Click on start simulation. Just click on start simulation coming. Just minimize this code. Minimize the code. Okay. So it is going safe condition, which means 24 centimeters is safe condition. Up to we write 100. Up to 100. 0 to 99. So just click on to 107, 103, 102, 109, 101. So 98 centimeter is safe. Just increase the minimum in 125 centimeters, which means warning. Okay, I'm going down, going down to 200 is a danger. Okay, 200 centimeters is danger. I'm going up, going up. So it is also danger. Okay, like that we can do this lot of experiment with help of ultrasonic sensor and LED.
Process of how to download the Arduino IDE step by step process. First go to the browser. Yeah, click on Arduino IDE here, search bar. After the enter, we can see here download option. This link will be given in the description, and click on Windows. Yeah, Linux and OX also is there. Just click on just download. Click on just download. The Arduino IDE software exe file is downloading. Is download. Click on open file. I agree. Next, install. So the Arduino IDE software is now installing. The Arduino IDE software installing. This is a process, it is installing. Just a moment, it is almost to complete the process. You can see here Arduino IDE is installing. Just a moment, just to within few minutes it will be completing the process of installing of Arduino IDE. Yeah, it is completed. Finish. Click on finish. It automatically open. Just a moment, I can see it in the desktop. It is opening. The latest version is, yeah, we know that the settings was changed, required to restart. Take a moment, please enter the button of restart Arduino IDE. Just click on restart. Yeah, it is restarting. Just a moment. So we know that, just for the reference purpose, zoom in. Yeah, just a moment. Yeah, we know that already. This is Arduino IDE software, and this is a void setup loop. Void setup, we know already what is the void setup and void loop. So void setup is we are initialize the pins, and we are declaring the pins, what is the pin type and what is the purpose of that pin. And next we know that while loop is, it is a logical loop, it is continuously work until the power up to the board. So click on board, sketch, just minimize it, purpose, just minimizing. Yeah, we know already we are minimizing. These are tools. Click on tools, go to the sketch. Now go on tools. Just a moment, what will happen? What is happen? Sketch. Just a moment. From here click on select board. Just I minimize the, just from here select the board. I'm select the board. So we know that already these are boards. We have a lot of Arduino boards are there. So click on Arduino 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 board. So click on Arduino Uno. So just click on it. Next go to the ports. So port 1 is, port 2 is not is there, but I'm not connected to the port. Just I'm connecting the board to the system with the help of cable. Is connected. We can see power is on. Power is on to the board. Just cancel this. Go to the board, and here you can select COM serial port USB, which means the serial communication developed between the system and board. So I'm go to the files, click on example program, because here we have plenty of example programs are there. First one is blink basics, click on blink, so that the blink basic program of blink will be open. We know that pin mode, the white, this is a white with, this is a white setup. This is a white setup from year to year, and this is a while loop. So in the white setup, pin mode, LED blinking, which means the LED blinking is connected to pin number 13, and pin type is output. So here in the logic, digital light LED blinking 13 and high, which means on 1 second, off 1 second. So we upload the program, first verifying, so done compiling, next uploading the program to the software. Uploading completed. We can see the blinking, the LED is blinking on and off, LED blinking on off. We can see that this is a program. You can change the delay to the 500, which means half microsecond, half second. Just I'm uploading the board. First, before uploading, the code will automatically compile. After the successfully complete, code will upload to the software. Okay, I'm uploading. I'm uploading. So you already see that the LED is blinking with the half second. Okay, we are changing the delay here. We am changing to delay 2000, and here also 2000. Just click on that, verify, is click uploading, done uploading. So we can see the LED is on 2 seconds and off 2 seconds. So on 2 second, off 2 seconds, we can see just on 2 seconds and off half second. Okay, click on that, uploading, done uploading, we can see here on 2 seconds, off 1 second, we can see here. Okay, like that we can do all the experiments.